Good day, Earth Science students. Welcome to video lecture episode 19. Today we're going to conclude our discussion on chapter 23, section 1. We're going to talk more about the moon and get some other information. Remember last time we talked about eclipses of the moon, so now let's go to the moon's surface. Now if you look at the moon, whether you look in the sky, you look in a textbook, look on an image of Google, you notice there's many depressions on the surface of the moon. We call those craters. These have come as a result of meteorites, asteroids, and comets, of course, striking the surface. And those are most of the reasons why those have been created. Now, upon impact, in other words, once a meteorite or an asteroid or a comet hits, the cracks may have been formed from the impact depending on how large they were. As a result, when those cracks form in the crust, it allows lava to reach the surface and then fill up those large craters. Now the resulting dark flat regions, as you can see on slide 109, are called maria. Alright? Now let's talk a little bit about inside the moon. Well, as we know, earthquakes have allowed scientists here on Earth to learn about Earth's interior. Well, in a similar way, scientists use instruments, as seen on slide 110, to study moonquakes. Yes, you heard me correctly, moonquakes. Keep it in mind, these are quakes that occur on the moon, so we call them moonquakes. Now let's move to slide 111. The data they have received from studying moonquakes has led to the construction of several models of the moon's interior. One such model is shown on slide 111, and it suggests that the moon's crust is about 60 kilometers thick on the side which faces us here on Earth. Now on the far side, it is thought to be about 150 kilometers thick. Well, under the crust, there's a solid mantle which may extend to a depth of about 1,000 kilometers. Now, a partly molten zone of the mantle may extend even farther down from that, and below this mantle may lie actually a solid, rich iron core, which is pretty cool to think about. Now, let's talk a little bit about the moon's origin, at least some theories and thoughts that scientists have had. Now, before the Apollo space missions in the 1960s and 70s, there were three leading theories about the moon's origin. According to one theory, the moon was captured by Earth's gravity. Another held that the material surrounding Earth condensed to produce the moon. And then the third one was an alternative theory which proposed that the Earth ejected molten material that became the moon. And like I said, these are the theories that scientists had before the 1960s and 70s when we had the Apollo space missions. Now let's talk about a theory that's fairly new, not the newest, but fairly new, and it's called the impact theory. Well, the data we gathered as scientists from the Apollo missions have led to many scientists to support a new theory, which is known as the impact theory. It states that the moon formed many years ago from condensing gas and debris thrown off when Earth collided with a Mars-sized object. Now, if you look at slide 160, I have an image just to represent, so you get that idea of what it means of a collision that they believe caused it, okay? Now, let's talk about the moon in history. Now, regardless of how the moon formed, it has played an important role. Studying the moon's phases and eclipses led to the conclusion that both Earth and the moon were in motion around the sun, which is, we know that, that's pretty cool, we've learned that. The curved shadow Earth casts on the moon indicated to early scientists that the Earth was spherical. When Galileo, in fact, first turned his telescope toward the moon, he found a surface scarred by craters and maria. Now, before that time, many people believed that all planetary bodies were perfectly smooth and lacking surface features. So as you can see, before we really started studying this, we just assumed everything out there was all smooth like marbles, but we've come to learn otherwise. More recently, actual moon rocks became available for scientists to study. If you look at slide 119, I have a picture of one of those. It's pretty cool. So that gives them more to study to learn about the moon itself in that way. Now, by doing so, by studying these moon rocks, they hope to learn more about Earth as well, because there's a connection with Earth and the moon, obviously, as you've seen by the various theories and the fact that it's close within our orbit. The moon was important in the past, and it promises to be important in the future as well. All right, ladies and gentlemen, this concludes our lecture today on Chapter 23, Section 1. I hope it's been helpful. Have a nice day. Take care. And remember, as always, if you would have questions, you can leave them in the comments below or reach out to me. Thank you. Have a nice day.